Hello, my dear mechanical champions. How are you all? What's up? कैसे हैं सब लोग? केम छो? अपोनकी मेनाचेन यल्लावनारू. This is Chandrashekhar, welcoming you all to the India's largest, the best, and your favorite live learning platform, that is BYJU'S Exam Prep. First of all, please do let me know if I'm audible and visible to you all perfectly, so that we can start our session. Hi. Styles, good evening. Welcome to the session. How are you all? कैसे हैं सब लोग? नमस्कार, आदाब, शुभ संध्या, good evening, सत श्री अकाल, अस्सलाम वालेकुम. So you guys are watching me live through the series, which is going to be helpful for those who are preparing for GATE 2023 examination. The series is Mastering Concepts for GATE 23. Good. Those who are watching me live, please respond through the comment section. Good evening, Ranbir, Priyadarshini. Welcome to the session. So please keep your pen, calculator, and paper notebook handy, because this is completely the practice session. We are going to practice some numericals from the basics of thermodynamics, basic concept, basic definition, as well as the first law. The topics for which the theoretical discussion had already been done the day before yesterday. Yes, Manas, good evening, welcome. So without wasting much of your time, without any delay, let us quickly start our session. So this is my quick introduction. Most of the students already know about me. Mechanical engineering graduate from IIT Delhi and also engineering services examination qualified. So I have brought around 12 questions from the basics and first law. So you should give me the answer through the comment section for each and every question. Whether your answer is correct or not, it does not matter. But your thinking ability, your approach definitely matters in scoring better in your actual examination. So I want everyone, those who are watching me live, I want each one of you to be part of this session with your full dedication, with your full communication, with your full involvement. Right? If you have anything to ask, you can just let me know through the comment section. Your doubts, I will be very happy to resolve all your queries. This is for mechanical engineering. Nani Bare. Applied thermo, Raju. पहले basic thermodynamics करेंगे, उसके बाद the last session is applied thermodynamics. Those who are coming to this channel for the first time, do not forget to like, share and subscribe the channel. We are providing you the complete guidance for GATE and engineering services examination. That is the timing. 8 p.m. is the timing for this series. That is Mastering Concepts for GATE 23. And to join Abhinav Negi Sir on 13th of March at 12:30 for getting the complete understanding about the strategy, preparation strategy and the complete guidance for GATE 2023 examination. Alright. So this is the timing, your style, UJ style. This is the timing. This is our mechanical branch. The timing will be 8 p.m. and the classes are going to happen on alternate days. Monday, Wednesday, Friday and Sunday. So today there will be class and tomorrow there will be no class. Day after tomorrow we will be having again. On Sunday we will be having again the class for second law at the same time 8 p.m. Alright. So this is my complete schedule. You can take the screenshot. This is how we are going to complete our thermodynamics. So we are here 11th of March. We are here practicing basics and first law. Then we will talk about the second law and then we will practice some numericals from the second law. Then entropy concept and practicing the numerical for entropy. And then we will talk about the applied thermodynamics. Alright? Yes, complete yoga. Raju. Complete matlab kya? What is the definition of complete? The topics which I have already mentioned in this slide, I will cover these topics. Complete thermodynamics cannot be possible in 10 lectures. So 5 sessions will be for practicing and 5 sessions will be for theoretical discussion, right? So the complete thermodynamics cannot be possible, but yes, the important concepts, the most important concept I will cover, and the remaining which are easier, which are not that important, you can study on your own. Self study you can do. So it is just like giving you a push to prepare thoroughly for your GATE 23 examination. All right, so shall we start? Are you all ready? Please write Y in the comment section for yes. If you are all ready with your pen, calculator, with all your weapons to be part of this practice session. Practice is very, very important in cracking any competitive examination. Without practice, you will never be able to succeed. Even if you know the concept, but if you do not practice the questions, it becomes difficult for you to clear the examination, difficult for you to get maximum marks in your examination. Okay, so let us start with the first question, warm-up question, very, very simple question. I want everyone to respond. Yes, I want everyone to answer my question. Answer first question. Heat and work are. Those who are part of my last session, even if you did not attend the last session live, do watch the recording. This is available on our YouTube channel. So about properties, path function I had discussed. What is the correct answer? Heat and work. They are the form of energy transfer. The energy transfer between system and surrounding can be possible in two ways, either heat transfer or work transfer. And that is why they are not properties. Heat and work are not property. They are not point function. They are path function. So because they are not point functions, properties are point functions. So that is why they are neither intensive nor extensive. I hope you are comfortable with intensive, extensive property. What are intensive and extensive property? The properties which depend on mass are called as extensive property. The properties which does not depend on mass are called as intensive property. I hope everyone is clear. So whenever we want to find out the change in work or the total work transfer in a process 1 to 2, that is integration of del W1 to 2, it will not be equal to W2 minus W1. I told you, because it depends on the path. Similarly, Q1 to 2, integration 1 to 2, del Q is not equal to Q2 minus Q1. That is why they are not point function, they are path function. But if I calculate the change in pressure or integration of dP between 1 to 2, we can call it as delta P or we can call it as P2 minus P1. They are point function. They only depend on initial. Properties are point function. These are called property. I hope it is clear to everyone. Let us move to the next one. Question number 2. The next question on the screen. Quickly. Everyone, please do respond. Again, very simple question. The expression integration of PdV gives the measure of work. In which condition? What is the answer to question number 2? Integration of PdV. Everybody please respond through the comment section. And if anybody is having anything to ask, you are most welcome through the comment section only. You can raise your doubt. Integration of PdV. That is closed system and reversible process boundary work. We call it as boundary work or moving boundary work. That is called as closed system undergoing a reversible process, and the work done by the moving boundary is called as integration of PdV. So closed system means non-flow. Closed system means non-flow reversible process undergone by closed system means non-flow process means closed system and reversible process. Option A is the correct answer. Option A. Clear? Yes. Option A is the correct. Manas, that was for previous question, is it? No. Why people have given the answer as B? Steady flow means open system. This expression is not for an open system. What is the expression for an open system? The next question, question number 3 on the screen. Which one of the following expresses the reversible work done by the system and the process undergone by the system as steady flow process? Which one of the following is correct? What is the correct answer? Question number 3. 3. Integration of PdV 1 to 2, that is W1 to 2 for a closed system. Reversible work or reversible process. And D is nothing, C is nothing. B represents the work done in case of open system, and the open system is undergoing the steady flow reversible process. Reversible process. It is always integration of PdV and integration of minus VdP. They are only applicable for reversible processes. So integration of minus VdP is open system, or we can call it as it is the control volume work. It is the control volume work. So option B is correct answer. Option B. B is the right answer. It should be negative sign. There is a negative sign. In last class, I had mentioned these things. So for a steady flow reversible process, the work done by the boundary of the system or boundary control volume, the work done by the control volume, it is control volume work. The work done by control volume, that is the work done by control volume. Is this clear to everyone? Do you know other forms of work transfer also? There are other forms of work transfer also. When do we call it as? Actually, if you have studied the basics, there are two ways in which energy interaction takes place between the system and the surrounding. Either in the form of heat transfer or in the form of work transfer. These are the two ways in which energy transfer is taking place. And when do we call it as heat transfer? The energy transfer due to temperature difference is called as heat transfer. The energy transfer due to temperature difference is called as heat transfer. Guys, that is how the formula is getting developed. If you are getting the value, if you are getting W as negative, if you are getting W as positive, then it is done by the system. And if you are getting W as negative, the work is done on the system. That is the sign convention. So this is the formula. Use the formula, and if the final value is positive, then the work is done by the system, and if the final value is negative, then the work is done on the system. Now I was talking about the work transfer. All the other forms of energy transfer is work transfer other than heat transfer. All the other form of energy transfer other than heat transfer are known as work transfer. For an example, if electrical energy is crossing the boundary of a system, listen very carefully. If the electrical energy is crossing the boundary of a system, then what do we call it? If electrical energy is crossing the boundary of the system, we call in thermodynamic definition, according to thermodynamics, we call it as electrical work transfer. We call it as electrical work transfer. We do not call it as heat transfer, because it is the electrical energy is not transferring due to temperature difference. It is called as electric work transfer. Example, electric heater. What happens in electric heater? There are other types of work transfer other than the control volume or boundary work. Integration of PdV is the boundary work. Minus integration of VdV is also the boundary work, control volume work. But there are other types of work transfer. When the electrical energy is crossing the boundary, then it is known as electrical work transfer. For an example, in case of electrical heater, there is water inside our electric heater, and what happens? The current is flowing through the coil. There is a current flowing through the coil, and due to current flow, what happens? There is a heating of the water taking place. So this is the boundary of the system. which energy is getting transferred or which energy is crossing the boundary of the system? It is the current which is crossing the boundary of the system. So the heating of the water is not due to heat transfer. The heating of water is not due to heat transfer. Heating of water is due to work transfer. Getting it or not? What work is transferred? That is electric work transfer. So do not always think there is a notion students are having. When I ask students, when I say when the system is getting heated, then which type of energy transfer or which form of energy transfer is taking place? Students keep telling me that it is the heat transfer which increases the temperature of the system. No, it is not always true. There is a possibility that the work transfer can also increase the temperature of the system. Is it clear? That is the work transfer, electrical work transfer. Similarly, let me take one more example, that is steering work. Steering work, or we can call it as paddle wheel work. Have you heard this? Paddle wheel. Can you just let me know the work transfer is positive or negative? This electrical work transfer, is it positive or negative? Is it positive or negative? Steering work or paddle wheel work. What happens in steering work? There is a system containing some liquid or a gas. There is a steerer attached like this. And there is a rope kept here and there is a weight. So what happens? This is the system. This is our system. Then here what happens is, due to the rising or falling of weight, let us say dz, the steerer will rotate. This is the steerer. The steerer will rotate. This is the boundary of the system. And due to steering of the liquid, the temperature of the liquid increases. The heating of liquid is taking place due to steering. Due to steering of the liquid. So here again, the heating is not due to the heating is not due to the heat transfer. It is due to the work transfer. That is called as steering work or paddle wheel work. That is due to work transfer. And because the work is done on the system, the work is done on the system, that is why it is negative. Because work done on the system, isn't it? So the electrical work is also negative and steering work is also done on the system. It is negative because it is done on the system. These are some basic forms of other forms of work transfer. Is this clear to everyone? They are negative. Murlidhar, Jeevan, they are negative. If you remember the sign convention, work is done on the system is negative, work done by the system is positive. Here the current is doing some work on the system, that is why the temperature of the system is increasing. Because the work is done on the system, the sign will be negative. It is a negative work. And similarly, the steerer is increasing the temperature of the system. So the work is done on the system, that is why it is negative. And heat added to the system is positive, heat rejected by the system is negative. Heat added to the system, you should always remember the sign convention that we carry throughout our discussion of thermodynamics. I hope it is clear to everyone. Any doubt? Then get yourself ready for the next question. Question number 4. Question number 4. Non-flow, it means closed system. Quasi-static, quasi means almost. Static means almost. Static means very slow. Almost static means very, very slow. And very slow processes are generally reversible. They are carried out with small changes. The slow processes are carried out with minute changes and they can be treated as reversible. So it is closed system reversible process occurs for which the pressure variation with volume is given by this expression. The unit is bar, where V is the volume. What is the work done when volume changes from 2 meter cube to 6 meter cube? Because it is a closed system reversible process. So can we say W is equal to integration of P dV from V1 to V2? Can you find it out? Can you find it out? The pressure 1 bar is equal to 10 to the power 5 Pascal. That is the conversion factor you are supposed to use. So the work transfer from 1 to 2 is integration of P is minus 3V plus 16 into dV or into 10 to the power 5. We need to calculate in joule. Pressure in Pascal multiplied by volume in meter cube becomes joule. Then it becomes the energy joule into dV. Do the calculation 2 to 3 and you will get the answer. I want everyone to respond. Everyone please do solve it and let me know the answer. Are you getting option A? So if I solve it, so it is 10 to the power 5 is constant into, it will be minus 3 into V dV is V square by 2 plus 16 into V and it is 2 to 6 will give you the answer. Put the value, you will get the answer in kilojoule. Minus 3 by 2, it is 6 square minus 2 square plus 16, it is 6 minus 2. Are you getting option A? Are you getting option A? Yes, yes, Manas, your style. Sagnik, well done guys, well done. Where are others? Where are other people? I hope it is clear to everyone. Shall we move to the next question? Question number 5 is beautiful. I want everyone to solve this question. It is about an ideal gas. Do you remember the ideal gas equation? PV is equal to mRT or we can write nR bar T. P is the absolute pressure, T is the absolute temperature, V is the volume, M is the mass, N is the number of moles. What is number of moles? That is mass upon molecular weight. R is specific gas constant and R bar is universal gas constant. I have already discussed these things in previous class. Can you let me know the answer to question number 5? Everyone, please give it a try and let me know the answer. Question number 5. It is constant temperature process. What is constant temperature? It is isothermal. Iso means constant property. Isothermal process. Temperature is constant. So for isothermal process undergone by an ideal gas, W122 is P1 V1 natural log of V2 by V1. That is the formula. And what is P1 V1? Can we write it as mRT? Is it lagging behind? Yes. Is the video lagging behind? Because mRT, T1 is equal to T2, natural log of V2 by V1, and mRT can also be written as N into R bar T into natural log of V2 by V1. That will give you the answer 1 to 2. What is the correct answer for question number 5th? I want everyone to give me the answer for question number 5th. Option A and D are quite similar. Option B and C are quite similar. The only thing is one is having a positive value, another is having a negative value. Manas had given the answer, Sagnik had given the answer, question number 5. N is equal to 3 moles, R bar is 8.314, temperature is 300 Kelvin, natural log of V2. It is compressed. Compression work is always negative because it is the work done on the system. Compression work is done on the system. Expansion work is done by the system. So V2 has become half of V1. So it is 1 by 2. That will make it as negative. So you will get minus 5 feet 188 kilojoule. Are you getting negative sign? Compression work is always negative. Compression work is negative. Work done on the system. Option D is the correct answer. Very nice. Well done, guys. Well done. Keep it up. Let us move to the next one. Question number 6. Question number 6. Quickly. Yes, Jivan, your style, Manas, Sagnik. Good, guys. Good. Well done. Question number 6 on your screen. This is PV curve. On y-axis, it is pressure. On x-axis, there is a process undergone by the system. The process is R2S. And PV diagram for the process is mentioned. So do you remember work done is area under PV curve? Integration of PdV. Will it be integration of PdV or minus integration of VdP? An ideal gas undergoes an isothermal expansion. Isothermal processes are shown like this. From state R to state S in a turbine. Turbine is called a steady flow device. It is open system. So W is equal to WR to S is minus integration of VdP. So that is area under, this is called as area under PV curve projected on what? Pressure axis. It is steady flow work. Projected on volume axis. This will be the area. This area will decide. This area is going to decide the amount of work done. This area. Can you find out this area? There is a rectangle and there is this portion. This area is already given. 1000 Newton meter. We need to find out this area. So work done for R2S is equal to, what is the area? This area. It is PR minus volume 0.1 into 2 minus 1, sorry, 2 minus 1 into 10 to the power 5. How much is that? So 1 into 10 to the power 4 Newton meter. WR2S will be W1, this 1 plus 2. This is W1 only. This is W1 only. This is W1. And WR2S is equal to W1 plus W2. So this will be 10,000 plus 1000 Newton meter. That will give you the answer. No problem, Yugant. Not a problem. Be there for the next question. Get yourself ready for the next one. So what is the correct answer? It is 11,000 Newton meter. Do you understand why I have taken the area projected on pressure axis? Because it is steady flow, open system. It is control volume work. Control volume work. Open system work. Right? Shall we move to the next one? C is the correct answer for this. Yes, Manas, it is open system. Turbine, compressor, these are all open system. Nozzle, diffuser. The next question, question number 7. The next question on the screen, sorry. Very simple. A closed system Question number 7. What is the answer for question number 7? A closed system undergoes the process 1 to 2, for which the values of Q1 to 2 and W1 to 2, positive and negative, they are signs have their own significance. In thermodynamics, the sign convention is having its own importance. Work done by the system is positive, work done on the system is negative. Similarly, heat added to the system is positive, heat rejected from the system is negative. You should take care of the sign. So the closed system is undergoing a process 1 to 2. There is a process undergone 1 to 2, for which there is a heat transfer and there is a work transfer, which are already given. If the system is returned to the state 1, it means it is becoming a thermodynamic cycle. If it is returning back to state 1, then it becomes a thermodynamic cycle, isn't it? What is thermodynamic cycle? When initial state is same as final state, and whenever it is initial and final state become same. Initial state is 1 and the final state has also become 1. If the initial state is same as final state, so the change in energy of the system will become 0 when it is undergoing a thermodynamic cycle, because energy is a point or state function. Do you remember? State function. Because change in energy of the system is 0, we can say energy in is equal to energy out. For a closed system undergoing a thermodynamic cycle, then we can say from the first law, that is the first law for a cycle. This equation is valid for reversible as well as irreversible cycle undergone by any system. Undergone by any system. Because the change in energy will be equal to 0. Change in energy will always be 0. Getting it? So, or we can write it as Q net is equal to, there is another way of writing the same thing, that is Q net is equal to W net. Or we can say Q1 to 2 plus Q2 to 1 is equal to W1 to 2 plus W2 to 1. There are so many ways to write the first law of thermodynamics for a system undergoing a cycle, thermodynamic cycle. For a system undergoing a thermodynamic cycle, either it is closed or open system. When a system is undergoing a thermodynamic cycle, the change in energy of the system will always be 0. So what is Q1 to 2? That is plus 20. And what is W1 to 2? That is plus 50. And if the system is returned to the state 1, the process is 2 to 1. So Q2 to 1 is minus 10. Then we need to find out W2 to 1. What is the value of W2 to 1? What is the correct answer for question number 7? Isn't it option B? Isn't it option B? How many of you are getting option B? Please make some noise. Nahi Ranbir. It is 10 minus 50 is equal to W2 to 1. That is equal to W2 to 1 is equal to minus 40 kilojoule. You should be clear with sign convention. Everyone should be clear. One incorrect sign will make your question incorrect. So let me quickly discuss the first law of thermodynamics. Let me quickly recap the first law of thermodynamics, which was not, which I could not discuss thoroughly in the last theoretical session. So first, before going further, let me first discuss the first law of thermodynamics. First law of thermodynamics is nothing but energy conservation. It is energy conservation law. It is energy conservation law, or we can also call it a Joule law. Joule's law. So for a system, we can say energy entering minus energy leaving is equal to change in energy of the system. That is our first law of thermodynamics. Energy entering minus energy leaving is equal to change in energy of the system. That is the first law of thermodynamics. It is like your income minus your expenses is equal to saving. That is the first law. Your income minus your expense is equal to saving. And what is the change in energy of the system? So we can say this is our general expression for first law of thermodynamics. For any system undergoing any type of process, this is the energy balance equation. That is why we call it as energy conservation equation. Income minus expense is equal to your saving. That is the change in energy of the system. Styles, again you have not used the sign convention correctly. When we are talking about, look, when we are talking about delta U for the process 1 to 2, then it will be U2 minus U1. But when we talk about delta U2 to 1, then it will be U1 minus U2, final minus initial. That is where you committed mistake, and that is why you are getting plus 20. Style. For the process 1 to 2, the change in internal energy will have different sign, and for the process 2 to 1, the change in internal energy will have opposite sign. That is where you committed mistake, isn't it? 1 to 2 process, the final state is 2, initial is 1. So U2 minus U1 is the change in internal energy. For the process 2 to 1, the final becomes state 1 becomes final and initial becomes 2. That is why there is a negative or opposite sign. Right? Clear? Now what is the change in energy of the system? Is equal to change in internal energy plus change in potential energy plus change in kinetic energy for simple compressible system. For a simple compressible system. And we talk about the compressible system only. That is the change in energy of the system. Delta U plus delta PE plus delta KE. And if it is a stationary system, or we can say delta E of system becomes delta U, that is U final minus U initial if it is a stationary system. For a stationary system, change in potential energy and change in kinetic energy is equal to 0. That is about the change in energy of the system. And what is energy transfer? This is the energy transfer. How to find out the energy transfer? Now let us talk about the energy transfer. E in minus E out. The energy transfer is taking place. E in minus E out is taking place in 3 ways. One is along with the heat transfer, in the form of heat transfer, in the form of work transfer, and there is energy transfer along with mass transfer. Heat transfer, work transfer, and mass transfer. That is E in minus E out. So how to write E in minus E out? Let us first talk about if it is a closed system undergoing a thermodynamic cycle. If it is undergoing a thermodynamic cycle. For a cycle, we can say delta E for system is equal to 0 for a thermodynamic cycle. So we can say E in is equal to E out. Or that is how we can write Q net is equal to W net. The energy, because for a closed system undergoing a cycle, the change in energy of the system will always be 0. Now, E in minus E out is actually Q in minus Q out plus W in minus W out. That is energy transfer in the form of heat transfer, in the form of work transfer, and in the form of mass transfer. Mass out. This is how the energy transfer. And for a closed system, mass transfer will be equal to 0. For a closed system, mass transfer is equal to 0. Because the mass transfer is equal to 0, so this term will become 0. So we can say for a closed system, it is E in minus E out is only Q in minus Q out plus W in minus W out, isn't it? For a closed system. Because for a closed system, mass transfer is equal to 0. Mass entering will be equal to mass leaving is equal to 0. For a closed system, there is no mass transfer. So energy transfer is like this. Or we can say, if we apply the first law of thermodynamics, so for a closed system, the first law becomes Q in minus Q out plus W in minus W out is equal to change in energy if it is a stationary system. Or we can say this is Q net is equal to delta U plus W out minus W in, and this W out minus W in will be W net. That is how we are getting Q net is equal to W net plus delta U for a closed system undergoing a process. That is valid for any process undergone by a closed system. That is how the first law of thermodynamics is developed for a reversible or irreversible process. I hope it is clear. Now, let me hide myself. Sorry, I forgot. So this is how Q in minus Q out is Q net, net heat entering into the system. W out minus W in is the net work done by the system. This is the net work done by the system. Is it? And plus this is the change in internal energy. And if there is a potential energy and kinetic energy change is also there, then we will put delta PE and delta KE also. Now for a flow process, if we apply first law of thermodynamics for a flow process, first of all, mass conservation, if we apply mass conservation for a flow process, we can simply say M in minus M out is equal to change in mass in control volume. For a flow process, we call it as control volume analysis. The analysis is done by using control volume. Volume is taken constant. So M in minus M out is equal to change in mass in control volume. How to write the energy conservation? That is E in minus E out is equal to change in energy of the system. That is how first law of thermodynamics can be written for flow process, and the flow process can be, that is open system, and the flow process can be steady or unsteady. They can be steady or unsteady. Do you know the difference between steady and unsteady process? If we talk about steady flow process, what is steady flow process? Property do not change with time. The properties do not change with time. So if we write mass conservation, M in minus M out is equal to delta M of control volume, or per unit time. If you write per unit time, we can say M dot in minus M dot out is equal to dm by dt in control volume. And because it is a steady flow process, there is no change in mass in the control volume. So M in M dot in is equal to M dot out is for a steady flow process. If there is a control volume, let us say this is our control volume. The mass is entering from this section, that is inlet. We are calling it as 1, and the mass is leaving from this section, that is outlet, that is 2. So we can say mass entering is equal to mass leaving per unit time, or mass flow rate is rho 1 A1 C1. That is the mass conservation. Rho 1 A1 C1 is equal to rho 2 A2 C2. That is how we can write the mass conservation, where C1 and C2 are velocity of flow. C1 and C2 are used as velocity. Why? Because V is used as specific volume. V is used for a specific volume. That is why here we use C1 and C2 for velocity of the flow. Is this clear? And similarly, if we talk about energy conservation, if we write the energy conservation, if it is a steady flow process, then the energy transfer will take place along with the mass transfer. 1 is entry, inlet, and 2 is outlet. So we can say in case of energy conservation, delta U will be replaced by delta H. Delta U, in case of steady flow process, delta U will be replaced by delta H in our basic energy conservation equation. Why? Because H is equal to U plus PV, and PV is called as flow energy. That is called as flow energy. So we can say Q net is equal to W net plus delta H will be the equation. That is, the unit is Joule. Delta U will be, or we can write it as, let me write the complete expression as delta H plus delta PE plus delta KE. That is the complete equation, or that is the first law of thermodynamics for steady flow process. This is the first law of thermodynamics for a steady flow process. Or for if there is no change in potential energy is equal to change in kinetic energy is equal to 0. So we can say, we can write it as Q net is equal to W net plus delta H. This is the expression. Or what we can write, so we can write Q net is equal to W net plus delta H plus delta potential energy plus delta kinetic energy. So potential energy is mgz, kinetic energy is equal to half mv square. If we write per unit mass, because mass is constant, because m dot I is equal to m dot E is equal to constant. So if we write per unit mass, or mi is equal to me is equal to constant, that is m. If we write per unit mass, so it will be Q net is equal to W net. You can write it as W net, small w I am using, plus it will be H2 minus H1 plus it is G Z2 minus G Z1 plus C2 square by 2 minus C1 square by 2. If we, this is the expression, so we can write it as H1 plus C1 square by 2 plus GZ1 plus Q net is equal to H2 plus C2 square by 2 plus GZ2 plus W net. Do you remember this expression? This is called as steady flow energy equation. This is called as steady flow energy equation per unit mass. Steady flow energy equation. That is for a steady flow process. The unit of each and every term is joule per kg. I hope you know this equation. That is for a steady flow process. Is this clear? Yes, that is how we are getting. Gamer Gupta. ये per unit mass है. Steady flow energy equation. And there is a possibility that the flow process can be unsteady flow process. Here, if the control volume is having unsteady flow, look, there is entry, inlet, there is outlet, and the system is also undergoing a state change. There is a process 1 to 2. There is a state change from 1 to 2. 1 is the initial state, 2 is the final state. Inlet is I, outlet is E. So here I for inlet or entry. In case of steady flow, there is no change in the state of the system. Properties do not change with time. That is why there is no change in state of the system. There is a state change also. In case of unsteady flow process, there is a state change also. So I for inlet or entry, E for exit or outlet, and 1 for initial state of the system. It is initial state, and 2 is the final state of the system. These are some of the situations when the flow process can be considered as unsteady. Charging of a rigid vessel, discharging a fluid from a pressurized vessel, inflating the balloons or tire. These are unsteady flow process. So property change with time. That is why there is a change in state. Property change with time, and that gives rise to state change. State change. If we write the mass conservation, we can say Mi minus Me is equal to M2 minus M1 for the control volume, isn't it? That is the mass conservation. So Mi will be equal to 0 if no mass enters the control volume. There is a possibility there is no mass entering the control volume. Me will be equal to 0 if no mass leaves the control volume. M1 is equal to 0 when the system is initially evacuated. Initially empty. And M2 is equal to 0 when the system is finally evacuated. This is how we can further modify the equation. Yes. I am not writing per unit time. For steady flow, it becomes important when we write per unit time. But here, no need to write per unit time. And similarly, if we talk about the energy conservation equation, so how the energy conservation will look like? That is E in minus E out is equal to change in energy of the system or control volume. So we can write, this is our energy conservation equation. So if we write, this is along with the heat transfer, along with the mass work transfer plus mass transfer. So we can say Qi plus Mi into Hi plus Ci square by 2 plus Gzi minus W this is Q net, sorry, this is Q plus Mi minus W minus Me He plus Ce square by 2 plus Gze is equal to delta U plus delta Pe plus delta Ke. That is the energy conservation equation. Mi is not equal to Me. And if potential energy and kinetic energy changes are negligible, if these changes are ignored, then what we can write, our equation will look like this. Q, this is Q net, this will be 0, this will be 0, these changes will be negligible. So we can say Q net plus MIHI minus W net minus MEHE is equal to delta U is M2 into small u2 minus M1 into small u1. That is our energy conservation equation when the change in kinetic energy and change in potential energy are negligible. Is this clear? That is all about the first law of thermodynamics. That is our first law of thermodynamics. I hope it is clear to everyone. Clear? Can we move to the next question now then? There is a question on the screen. Now you are supposed to solve. I have given you each and every detail about the first law of thermodynamics. Nozzle, these are steady flow devices. Nozzle, diffuser, turbine, pump, compressor, heat exchanger, etc. Throttling device, these are steady flow device. These are all steady flow devices which are undergoing the steady flow process. Now there is a gas flowing through an insulated nozzle. What does that mean? Q is equal to 0 or small q per unit time because these are steady flow devices. If the inlet velocity of gas is negligible, so C1 is 0 and there is an enthalpy drop. So H1 minus H2, because there is a drop, H1 minus H2 is equal to 45 kilojoule per kg. So in terms of joule per kg, it will be 45,000. The velocity of gas leaving the nozzle is C2 is calculated because they are all steady flow device. So steady flow energy equation will give you H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W. C1 is equal to 0, Q is equal to 0, GZ1 is equal to GZ2. So it is H1 is equal to H2. The work done is also 0. The nozzle is not used to do work. H2 plus C2 square by 2. That will give you the answer. So what is the value of exit velocity? So C2 is equal to 2 H1 minus H2 under root. What is the correct answer? Do not forget to convert this kilojoule in joule. You should always put all the parameter in their SI unit. So it is 45 into 10 to the power 3. So it will be C2 is under root of 90,000, isn't it? So that is 300 meter per second. Option C is correct answer. Are you getting option C? Option C will be the right answer. The next question, question number 9. Question number 9 on your screen. Along a path 1 to 3, a system absorbs 100 kilojoule as heat and performs 60 kilojoule of work. While along path 1, 4, 3, there are two paths. This is 1, this is 3. These are initial and final state. This is process 2. And there is another path 1, 4, 3. It is not a cycle. It is not a cycle. Cycle would have been when the initial and final state would have been same. So we can say, because delta U in 1, 2, 3 will be same as delta U in 1, 4, 3. Because the initial and final states are same. So change in internal energy will be same. So we can say Q123 minus W123 is equal to Q143 minus W143. Or we can say Q123 plus can you solve it? Or we can say Q net is equal to W net. Q net is equal to W net. A system absorbs 100 kilojoule. In the path 1 to 3, a system absorbs 100 kilojoule as heat. So it is plus 100 because it is heat added to the system and performs 60 kilojoule. So work is done by the system, that is plus 60. There is already a negative sign, is equal to along path 1, 4, 3, the system performs 20 kilojoule of work. So plus 20, heat absorbed Q143 is how much? What is the correct answer for question number 9? Isn't it option D? So it is 100 minus 60, that is 40 is equal to Q143 minus 20. So Q143 is equal to plus 60. D is the correct answer. D is the right answer, definitely. Now this is your turn. Now it is your turn. Question number 10. Everyone, please give it a try. In an adiabatic process, it means there is no heat transfer. 500 joule of work is performed on a system. So Q is equal to W plus delta U. So this is equal to 0. 5000 joule of work is performed on the system. So it is minus 5000 plus delta U. The system returns to its original state while 1000 joule of heat is added. So what we can say, there is a process A, 1A, 2, and it is returning back. So this is process B. Because it become a thermodynamic cycle, what we could have done is Q net is equal to W net. First law of thermodynamics. Q net is equal to W net. We could have said QA plus QB is equal to WA plus WB. QA is equal to 0 and WA is equal to minus 5000. Work done on the system is negative. The system returns to its original state while 1000 joule of heat is added to the system. So it is plus 1000. What is the work done during non-adiabatic process? What is the correct answer for question number 10? 10 also will have C option. 10 will also have C option. No, style. 10 will also have C option. WB is equal to plus 6000 joule. Isn't it plus 6000? Question number 11. Very, very beautiful. Now, I want you to solve this question. Question number 11. I want everyone to solve. And day after tomorrow, we will be meeting for the second law of thermodynamics. I am about to stop. Give me the answer for question number 11. You should take care of the sign. A gas contained in a cylinder is compressed. The work required for compression being 5000. So W is equal to minus 5000 kilojoule because work is done on the system. During the process, heat interaction of 2000 kilojoule causes the surrounding to be heated. It means the heat is rejected to the surrounding. So Q is also negative. W is negative, Q is negative. The change in internal energy. So Q is equal to delta U plus W. Q is minus 2000. Delta U is change in internal energy plus W is also minus 5000. So what is delta U? That is 5000 minus 2000. So change in internal energy is plus 3000 kilojoule. Isn't it plus 3000? C is the correct answer. Isn't it option C? Yes. C will be the right answer. And the last one, last question for the day. The first law of thermodynamics takes the form W is equal to minus delta H. Or we can say 0 is equal to W plus delta H. So Q is equal to W plus delta H. This was our question. So that is valid for, what is the correct answer for question number 12? I hope everyone will be able to give the correct answer. Whenever the enthalpy comes into picture, it cannot be a closed system. It cannot be a closed system. It cannot be a closed system. It is an open system undergoing an adiabatic process. Adiabatic means heat transfer is zero, insulated, with negligible change in kinetic energy and potential energy. So option B is the right answer. Style, it is B. B is the correct answer. Alright, so guys, that is all from my side for the day. I hope you have enjoyed the session. You have improved your understanding about the basics concept as well as first law of thermodynamics. Those who are not feeling comfortable still, you can watch the recording again. You can note down, you can make the notes on your own and then practice more and more numerical. I will share the PDF for the session. Definitely, I will do that. That is all. Enjoy your day. Take care, stay safe, stay motivated. Thank you guys. Do not forget to subscribe our YouTube channel so that you will be getting the notifications for all these classes. And I will see you day after tomorrow at the same time, 8 p.m. and we will discuss the beautiful second law of thermodynamics. Till then, take care, good night and stay safe. Thank you guys. Jai Hind.